Okay, let's dive right into this explainer. We are literally on the verge of solving the ultimate cosmic detective story. We're going to be tracking a trail of evidence stretching from the deep freeze of interstellar space all the way to the dusty surface of Mars, as we unpack the search for extraterrestrial life. So are we alone in the universe? For centuries that was purely a philosophical question. But today, we're actually getting closer than ever to a definitive scientific answer, thanks to some mind-blowing discoveries happening right here in our own solar system. Now, to be clear, scientists aren't peering through telescopes hunting for little green men. Instead, they're hunting for biosignatures. These are potential signs of ancient life on other worlds. Think chemical or structural traces left behind by microscopic organisms a really, really long time ago. And to find them, we first need to find the raw ingredients.
Section 1. Life's Ingredients on Menu.
Let's kick things off out in deep space. Through NASA's OSIRIS-REx mission, we managed to bring back a pristine jar of dirt from an asteroid named Bennu. Because it's been preserved in the absolute vacuum of space for 4.5 billion years, this regolith is basically an uncontaminated time capsule of the early solar system's chemistry.
And what researchers found inside this dirt completely rewrites the textbook on what existed before life started on Earth. Just look at this number, 14. Out of the 20 specific amino acids that life on Earth uses to synthesize proteins, the literal building blocks of biology, researchers found 14 of them naturally occurring right there in the Bennu sample. No way, right?
It really shows us just how abundant life's toolkit is out in the cosmos. They found all 5 canonical bases for DNA and RNA, those 14 amino acids, high abundances of volatiles like ammonia and formaldehyde, and even a complete set of water-evaporated salts. It brilliantly illustrates that the chemical precursors for biology, like an ancient hydrothermal broth, were widespread across the solar system even before Earth was fully formed. But as Tim McCoy from the Smithsonian points out here, you can have all the ingredients for whatever you want to make, but you have to have the environment to make them do something. A freezing void just isn't going to cut it. You need a warm, wet place for those ingredients to spark biology. And that leads us to our prime suspect.
Part 2. Mars, the lost ocean world. So, today, we all know Mars is a cold, dry, barren desert. But thanks to the MAVEN orbiter sniffing the Martian atmosphere for over a decade, we know it wasn't always this way. Look at this comparison. Ancient Mars was radically different. We're talking a warm, wet world with rivers, lakes, and deep oceans, the perfect environment for life's ingredients to take root. So, what exactly happened to all that water?
Well, the answer lies in this number. Earth has a global magnetic field to protect it. Mars doesn't. Because it's completely defenseless, the violent solar wind strips away about 100 grams of the Martian atmosphere every single second. Over billions of years, the planet's protective blanket was literally just blown away into space. It's a pretty tragic planetary transformation. As Vicki Hamilton notes, the mission provided the strongest evidence yet for why Mars went from a warm, wet world to its current cold, dry state. With its atmosphere gone, the oceans either boiled off or froze, trapping any potential evidence of past life deep within its ancient, dried-up rocks.
Part 3. Perseverance and Cheyava Falls.
This brings us to the scene of the crime, Jezero Crater in ancient Martian lakebed. Exploring a region nicknamed Fallbreen, NASA's Perseverance rover has actually encountered some of the oldest terrain we've ever seen. We're talking rocks that might potentially even predate the Jezero Crater itself.
To look back in time, the rover carefully drilled a tiny, 5-centimeter wide abrasion patch into the surface. That little drill hole acts as our magnifying glass, allowing the onboard instruments to analyze the freshly exposed, unweathered interior of the rock. And what they found inside a highly intriguing rock, nicknamed Cheyava Falls, is, well, it's nothing short of a smoking gun. The data revealed structural and chemical evidence that it may have once been home to ancient microbial life. This is absolutely huge, guys. We might have finally found traces of exactly what we've been looking for.
Part 4. The Mars Sample Return.
But here's the catch. A robot can't definitively prove these are biosignatures. We really need them here in Earth's state-of-the-art labs. Enter the Mars Sample Return, a 3-step logistical masterpiece. First, collect. Perseverance drills and seals small rock cylinders into sample tubes. Second, land. A sample retrieval lander touches down nearby in the crater. And finally, return. The tubes are launched right off Mars and brought back to Earth.
As we wrap up this explainer, I really want to leave you with this thought. If those tiny rock cylinders return to Earth containing undeniable evidence that biology sparked on another world, how will it change our understanding of our place in the universe? We're standing on the precipice of finding out that life is not just a unique accident here on Earth, but a fundamental, inevitable part of the cosmos. Keep looking up, and thanks for exploring this with me.